So the next type of reaction we'll look at is called displacement reaction. In this, I'll have a reactant which I'll have two parts and one with one part, something like this. So if I look at one reactant, it will be like AB, like this, and the other one will have C. Okay, if I use these reactants, then one of them is going to switch places. Okay, the parts are going to take a switch and it will give me something like A plus BC or CB. Okay, so AB and C are my reactants, and when I get the product, it will be A plus BC or CB. Okay, let's go ahead and look at what is the activity look like. So for this activity, I'm going to need something called zinc metal. Okay, I'm also going to need acid and test tube and something to hold the test tube, a holder, and a small filter paper to collect. Okay, so for my first step, I'm going to use this zinc metal, which is in the form of a powder. It can be in pure metallic form also. So I'll collect some of this zinc metal powder, and I'm going to try to pour this carefully into the test tube. So I'll either try to break it apart, or I'm going to just pour it slightly carefully. Since it's a metal, it might crack my glass. So I'll slowly pour this powder in the test tube like so. Okay, great. Almost, yes. Okay, this should be good. Now here is my metal in my test tube. Okay, one of my reactants, which is zinc metal. The next thing what I'm going to do is I'm going to take hydrochloric acid, which is my next reactant, and be careful, it is acid, it's quite strong, even though this one is dilute. So always be careful. It smells also really pungent. So first I'll pour it in this beaker so that it's easier to pour it. Okay, now I'll just put the beaker aside and I'll close the cap really tight like so. Now I'm going to pour this acid into this test tube like that, carefully, very slowly. Now notice that the moment the acid has hit the metal, you'll see small bubbles that are coming out of the metal, right? Just look carefully, right? Some bubbling is happening. Now what I'll do, I'll just close off the mouth of this test tube with a balloon. I'm using a balloon specifically because you're going to observe something that happens with this balloon. Okay, now bubbles generally mean something for us. That's what we are going to try to look at. Okay, you'll see that in some time this is going to inflate a little bit and it's going to look something like that, right? Now something got collected inside the balloon. That's basically a gas, right? Now this reaction has given us a gas. So what happened over here is a zinc metal and hydrochloric acid underwent a displacement reaction wherein the hydrogen out of hydrochloric acid gets separated. Okay, so zinc and the chloride are combining with each other and forming zinc chloride, and the hydrogen that remains is forming a gas. So Zn plus HCl gives us ZnCl2 plus H2. This H2 is what is coming out as bubbles, and those bubbles as gas are ultimately getting collected in our balloon. So this is an example of a displacement reaction. So the next type of reaction that we are going to look at is double displacement reaction. It is similar to displacement, but over here you're going to have two reactants with both having two parts. Okay, so right now the displacement will happen for both. From each compound, one of them gets displayed. So if I think this as A and B and this as C and D, okay, so my reactants will be AB and CD. The switch is going to happen something like A and D and C and B. Okay, so this is an example of a double displacement. We'll go ahead and look at an activity for this. So for a double displacement reaction, I'm going to need two reactants. One of them is this lead nitrate, another potassium iodide. I'm going to need beakers to make solutions and distilled water. Okay, so for my first step, I'm going to just add this water to these two beakers to make the compound solutions. So now take each of these salts. I'll start with the lead nitrate and just take a little bit of it, usually not in your hand, take it with a spoon, but I didn't have one. So this is my first solution of lead nitrate. Now once you're done with this, you take the next salt, that is potassium iodide, and you create a solution in the same way of potassium iodide, add it to the other beaker, right? A little bit of salt, and then you just make sure the solutions are mixed properly. You can stir them, shake them, either way, just make sure the salts are dissolved, something like that. Once our solutions are ready, we can proceed with the reaction. So remember, our reactants are both solutions, both of two different salts, okay, potassium iodide and lead nitrate. Now these are ready. So this is my potassium iodide, this is my lead nitrate. Now what I will do, I'll go ahead and I'm going to mix one of these solutions in the other. It doesn't matter which one you can add to which, it'll still work. Okay, so just keep looking at the color to notice what is changing whenever your solutions are being added. Okay, so now you will see that the color of this has completely changed. So my lead nitrate and potassium iodide have reacted. So what happened over here is lead nitrate is a compound made of lead and nitrate. Potassium iodide is a compound with potassium and iodide. So that is basically our AB and CD. So the nitrate changes its place from lead and goes to potassium, and the iodide changes its position from potassium to lead. They basically switch these ending parts with each other. That's exactly what gives us this bright yellow color, because the new compounds that are formed are this dark yellowish in color. Okay, so that is how this reaction of double displacement is working. So that's it for today. For now, we have looked at 4 different types of chemical reactions, and we are gonna go ahead with the chapter from the next class. So if you have any questions, doubts, please drop them in the comments below, and I'll see you again in the next class. Thank you very much.